Thank you very much for the invitation to speak to you today. I hope you can cope with my Glaswegian accent. I still haven't lost it. Another Glaswegian I just heard from the audience there. Thank you very much for the invitation to speak today. This is the first time I've given a talk which tries to integrate some of our basic research into the more sort of public health related themes. As just been mentioned, you would have seen some of our work on the BBC Horizon programme, but the truth, as I hope I am able to convince you tonight about exercise, is perhaps slightly more shocking and slightly more interesting and intriguing than even was alluded to in that programme. But for sure I've stolen the title from that programme, and I'm going to continue to use it because it's rather good, I think. So most of my slides tonight are some simple science concepts, some text, some health messages. Every now and again there's a little blue box down on the left hand side, and that's the sort of small print. So while I'm telling you about a particular fact or a particular half-truth, as most things are in science, you can glance down there and either find the source of the information, or you can find one of the caveats to what I'm just telling you. So you can choose to believe the main slide, or you can choose to believe what's down on the left-hand corner. This was the abstract that I provided for this talk, and each thing in red really points to some of the highlights of what I hope I'll present this evening in a convincing manner. To cover each in detail would take in itself an hour, so I'm clearly not going to touch on every one of these points in a lot of detail. So why do we exercise? Or perhaps more importantly, what does exercise mean to you as an individual? And this is really where the trouble starts, because if you ask 100 people about exercise and ask them to use words that it relates to, they'll all come up with different motivations, they'll all come up with different definitions of what health is, what health expectations they aim to get from exercise. And in fact, it's not just people that do that. Our public health message is very much mixed as well. The levels of evidence for each of these different benefits, such as reduction in diabetes risk, or impact on cancer risk, or impact on mood, for example. All of these have different levels of scientific evidence, and some, in fact, have very little scientific evidence at all. But the problem is that if every one of those types of endpoints is rolled into this concept of fitness, things become rather confused. And so really what you have to do is pay attention to the endpoint that you're interested in. So if you're interested in looking at how exercise will reduce your blood pressure, if your blood pressure is elevated or you have hypertension, then you need to focus on the evidence that exercise is good for hypertension or exercise is good for blood pressure. Now that seems rather obvious, but if you go onto our sort of public health websites, you'll see all of these ideas mixed up. Probably the one that's most confusing to most people is obesity and overweight, and this interaction between exercise and obesity. You can be extremely fit metabolically but obese. You can be slim and quite unhealthy in terms of your metabolic fitness. And so the two are not synonymous. The two are not directly linked in the way that is often portrayed. They're linked in much more complicated ways than exercise alone can cure. So first, the good news. Here's the sort of headlines that drive our public health message, and that is that if you have a healthy lifestyle, you'll live about 10 years longer on average. It may even feel longer than that. That's a pre-prepared joke, of course. It's a little bit like my time in Sweden. It was a very quiet time, and it did feel quite a long period, even though it was only 3 years. So you can do all of these 5 behaviours, and there are many excellent studies looking at the impact of these 5 behaviours. So not smoking, trying to maintain a body mass, in particular a body fat mass that's proportional to your height. often measured by the BMI calculation, which we know is very problematic. Taking regular physical exercise, and in, of course, this case, based on the public health messages we're bombarded with, this is 150 minutes of exercise a week. And as I'll come to show you, I think that is not necessarily true. A diet low in fat, but we're not sure which kind yet, and a diet high in plants, but what kind of plants? If you look at a bottle of appetizer and a fizzy, sugary apple juice, you'll see on the cap it's 1 of your 5 a day, and yet no one could really argue that must be true. Light to moderate alcohol, under 20 units a week if you're male, depending which country you go to. In Denmark it's under 14 units per week, although I've never met a Dane that drinks less than that. I think the key point here is, and it's of course highlighted in red, is how important is exercise in this mix? And that's something I hope to address partly tonight. So if we look at exercise capacity or physical activity, those are two distinct parameters, and death or all-cause mortality. You can see two very well reproduced phenomena, and that is that people that report as being active have a better health. People that are measured, or a surrogate is measured that they're fitter, have a better health, and therefore this is considered a truth, if you like, that directly linking fitness, whatever fitness means, exercise behaviour and health. But this is perhaps too important a small print to put in the small print, and I'll give you time to read this. I think it's really important. It doesn't matter how large the study is or how often an association is reproduced. The data cannot and does not prove that if you take a person, an individual person with low physical activity, make them more active, that this will provide that individual with benefit. In order to know this, what you need to do is you need to intervene. You need to take that individual, put them on a training program and measure the outcomes. Now, luckily we do have some very nice data that's at least looked at lifestyle modification. So this is a very highly cited study which compared the anti-diabetes drug metformin with a lifestyle modification program. And the conclusions of the authors in this paper was that if you could actively improve the lifestyle, which is related to those 4 or 5 parameters I put up earlier, then you can reduce the risk of developing diabetes. And there are many studies now which are showing essentially the same thing. Based on that, and based on the enthusiasm around the fact that you can really target and have a big impact on diabetes or insulin resistance with an intervention program, a lot of people began to put 2 and 2 together and get perhaps 4.5, 5. So the thinking went along these lines. So if you modify exercise and perhaps also diet regulation, then this would have a powerful ability to reduce the development and or progression of type 2 diabetes. Type 2 diabetes patients have more cardiovascular disease, and that is actually one of the main motivations for treating your diabetic patient. They don't die per se of high glucose levels, they die of the complications that those high glucose levels induce. And that's what also causes costs, rather, the NHS so much money per annum. And so the thought now was lifestyle interventions therefore should reduce the major cardiovascular complications within these patients. Small prints there for you. I won't spoil the story. So what happened when this was trialed? There are 3 studies. Top one here is the Finnish diabetes prevention study, 10 years follow-up in about 600 people. So not a terribly large study, but a pioneering study, one of the first that got away from this correlation type analysis and did an intervention and hoped to impact on the outcomes of the subjects taking part in the intervention. They were pretty successful at reducing the incidence and progression towards type 2 diabetes in this population. Look Ahead trial just published its last major announcement, I would guess, 2012. Here they took about 5,000 subjects that were overweight, already had type 2 diabetes, and put them on an intensive lifestyle intervention program that included increased physical activity and also modification of the diet. What happened? If you focus on the major cardiovascular events, then essentially nothing happened. In fact, the NIH stopped the Look Ahead trial early this year. Some of you that are familiar with some of the work that's taken place over the past 15 years or more, the UK PDS trial, observational analysis, knows that one of the major risk factors in terms of cardiovascular disease linking diabetes to healthcare resource utilization is microvascular disease. So things like, for example, blindness, ulcers, things like that. It seems to be the case that if you go in with an aggressive lifestyle modification program that increases your physical activity levels, modifies your diet, and reduces your chance of having type 2 diabetes, it doesn't actually give us that long-term benefit on cardiovascular, macrovascular disease that we expected, or some expected. What about exercise only? Well, if you look for supervised exercise-only studies that have went in and shown a long-term disease progression, we don't have any. Not a single major supervised intervention study that links in a causal way all of the very, very powerful, large epidemiological data sets that we've got. And it raises a number of interesting scientific questions, because for sure we can cluster metabolic disease and cardiovascular disease together, but the reason why we cluster it is unknown. And of course we've assumed that it's been because of shared environmental factors. It could well be because of shared genetic factors, for example. So let's take a step back and look at what exercise advice we're actually given. And this is just a snapshot from the NHS website, and essentially it's a phenocopy of what the ACSM, the American Heart Association, the American Diabetes Association, and so forth would recommend. And these are just pulled off some of the facts that they try and guide us by. So, first one is aerobic exercise. For it to be beneficial, it must raise your heartbeat and make you sweat, which is interesting. The second one, the more exercise you do, the better. And then we have our minimum 150 minutes per week. If you go beyond 150 minutes, then you will gain even more. The last one I just think is fascinating, because I don't know how many of you skip, but if I tried to skip, I'd end up in the casualty department more often than not. Why that's recommended as an example of vigorous exercise, I do not know. Anyone who knows about skipping knows you're pretty much using very small muscle masses when you're doing it. So you have to ask a number of questions. If this is our public health policy, you have to ask a few questions. And one of them, which was raised in the introduction, is this sort of advice achieving its aims? And the answer is no, because of the fact that nobody's really following these guidelines. And there are multiple reasons for that. And one for sure is the time barrier. Whether it's a perception or whether it's real, it's the thing that's named by many, many people. Perhaps as a scientist, I'm slightly more concerned about the second one, which is the advice based on solid scientific fact? And again, the answer appears to be no. It's based on our best guess at the moment. And that leads on to the final point, why are we given these guidelines? And that is simply because in the absence of anything more than the data we have, we'd have to say nothing. What I'll hopefully raise in a suitably controversial manner in the next few slides is questioning whether doing something is better than nothing at all. Okay, so there are no supervised long-term exercise intervention studies that show, for example, an impact 10 or 15 years later, but what we do have is a lot of data which is intervention-based that show that you can really superbly modify, on average, risk factors for future disease. And really, this is the vast body of evidence that drives our public health policy. So, for example, we know that exercise will increase aerobic capacity in about 80% of people. It will improve insulin action in about 65% of people. It will reduce blood pressure, perhaps not as effectively as one might think. It will increase the HDL in your circulation, the good cholesterol. And it'll promote muscle and bone mass, but there's less data on what percent of responders we have for those particular endpoints. And here you can see that all of these are considered risk factors for various major health problems. So again, we've got strong evidence linking biomarker, if you like, or risk factor with important public health things. And I think that's a reasonable place to start because that's essentially the level of evidence we've got. So the next question you have to ask yourself is, well, what type of exercise should I do to achieve these risk factor modifications? And how much and how often should I do it? If we look at the 150 minutes a week that we're all supposed to do of moderately intense jogging or cycling or whatever it happens to be, these are the types of responses that you see in a population of, say, 800 people. This is work by my colleague Claude Bouchard, and it's a heritage family study carried out in the USA. On the left here, what you have is a graph of the improvement for each individual. There's a solid black line going up the way. The improvement in aerobic capacity. So the units are not terribly important. The average improvement is 15%. But as you can see there, we've got some people who have a superb increase, dramatic. We have some people who, in terms of test, retest in the lab, they look worse after the training. Our test, retest reliability actually tells us that we can't distinguish anyone in that bottom end there as being someone who's actually changed from baseline. Now, that's of course for aerobic fitness, but if you then think about diabetes and diabetes risk, you have to then look at how well your insulin is functioning in the body. And this is a graph again of the improvements. So you have the people, again, just as the first graph, lined up and down, and each line indicates either a decrease in value, which in this case is a positive thing, no significant change, or actually some people going in the opposite direction, and I'll touch on those people in a little while. The key point here is everyone responds differently, and this is really, really important because all of these people went on the same exercise training program. They all followed, if you like, the standard 150 minutes of exercise. Each session in this case was supervised, so it wasn't the case that these people here were doing more exercise than those guys. There was no relationship to their baseline fitness and the response they got. So then you have to ask the question, well, as an individual, what is the right or correct exercise advice for you? Are you doing the right exercise? Should we all do the same amount? Could we change those graphs so we gave some more training and other people less training? How do your other lifestyle choices impact on these factors? If you don't get your nutrition right, will you undermine any chance of getting a benefit from your exercise? And really what I'll now focus on is, do you really need this 150 minutes a week? So a little bit of basic science around exercise intensity, because this is really important. to understand what we're talking about when we talk about high-intensity interval training. So, the types of exercise intensity, what you have here is a graph of the amount of oxygen you're consuming during the exercise work, and this is the amount of work you're doing. And as you increase the amount of work, of course, you're increasing the amount of oxygen you're consuming up to a maximum level. After that point, all the work you're doing is coming from, if you like, energy stores within the muscle. You cannot keep going on forever. As soon as you start exceeding this particular value here, the duration of exercise is measured in minutes. If you're a world-class athlete, you can maybe do 10 minutes. If you're average person, you maybe can do about 30 seconds, 1 minute. Most of the exercise that we do, physical activity, daily life, is down here, right down at the bottom. And in fact, most of the guidelines that inform us and tell us to do physical activity aim to suggest that we do exercise down in this sort of zone here, somewhere between 50 and 70% of our maximum aerobic capacity. When we started working with the high-intensity interval training programs in a variety of populations, really we were working with a type of exercise that really was more commonly found in the athletic training environment, and it really works up here in this zone. Now, one of the reasons why it was ignored, largely ignored for about 20 years or 30 years, is principally people thought that down here you did this type of training to burn fat and gain aerobic and cardiovascular fitness, and you did the training up here to gain power, speed, and drive metabolism. They didn't really think that doing exercise up here would give you a good cardiovascular benefit, and really it was my colleague Marty Gabala and McMaster that did the first study to show really that you can impact on cardiovascular profiles. So the types of HIIT study that we've been doing over the past few years are quite variable, and there's no magic formula. Any blend of these would probably be quite effective. Marty started off by doing 30-second, very intense bouts on a cycle ergometer, followed by a couple of minutes of just sitting there or very light pedaling, doing your 60 seconds again, 30 seconds again, and repeating 6 times. So that would be about a 15-minute period, 6 times 30 seconds. Later on, and part of the EU trial that we now currently are rolling out in overweight and insulin-resistant people, we've modified this to make it slightly less intense, but to try and keep the total duration of exercise about the same. What many of you might have observed on the BBC Horizon programme, however, was a much simpler model. And I'm going to show you some data from various studies. So here we're talking about 3 times 20 seconds of exercise, giving it a full effort, and that's it. You then repeat that 3 times a week. So this is something, as Michael showed in the documentary, that you can do in your suit. You can do it just before you've had your toast, just after you've had your toast, although I wouldn't recommend it. You can pretty much fit it in any time. And in particular, I think it's got a lot of potential for fitting into the workplace, because you don't need to change. You do not sweat, and therefore we can't use sweat as a terribly good guidance for whether you're going to get your health benefits from exercise or not. And really, what I think this work is showing us is that time is not a very good measure for understanding the link between physical activity and the health benefits. So here's just a couple of pieces of data. This is in young sedentary people that did very little exercise. We put them on a 2-week training program. On the left here, what you can see is the rise in blood glucose levels after we give them a sugary drink, so about 75 grams of sugar, in this case glucose rather. This is the rise in the glucose and the fall. That's the response post-training. So in actual fact, what we did here is we missed the peak. They were so effective at reducing their glucose back down to resting levels, we actually didn't sample early enough. If you look on the right-hand side, what you see is the insulin levels. And again, we probably missed the peak here for insulin, but the general pattern is very, very clear. After just 2 weeks of this sprint interval training, they required less insulin and were able to clear the glucose more rapidly after drinking the glucose. And that's essentially what you're trying to achieve in a diabetic patient, or what any of us are trying to achieve after we eat. We take in foodstuffs, we want to clear the glucose into our muscles, into our adipose tissue if need be, resynthesize liver glycogen. But essentially we don't want glucose or high levels of glucose circulating in the bloodstream. What was most interesting to us was the fact is you don't normally see this with regular aerobic training. This size effect here, if you like, was much bigger than what we normally encounter in a young sedentary population. Really, you only get this type of size effect when you go into people with impaired glucose tolerance. So it looked like the HIIT was more effective. There's been other studies looking at various other endpoints. So for example, in Maureen McDonald with Marty Gabala have looked at various endpoints in terms of vascular function and shown that 6 weeks of the 7 minutes of exercise training is equally effective as a classic training program. There you have the change with the classic training program. There you have the change with the 7 minutes of sprint training. And what this data is really just showing you is you're getting the same effects, but you've got 7 minutes of training in one hand and you've got 150 minutes of training in the other. So very, very clearly we're taking time out of the equation. There is some other aspect or stimulus from exercise that gives these physiological changes or health benefits. What about middle-aged or diabetic subjects? It's pretty much the same story. Again, this particular study here is from the Gabala lab, and what we're doing now is we've got a electrode put within the subcutaneous fat of the subject, and it's detecting the blood glucose levels every time they eat. And here you can see that in these particular individuals, they don't have good glucose control. They show the typical postprandial or post-eating excursions in blood glucose. And you can see there that those excursions are less after your 6 weeks of HIIT training. What you can also see is that 72 hours after the last training session, you've still got an improvement. So in this case, a decrease in this parameter is an improvement. While after traditional aerobic training, 72 hours later, you no longer have the same size of benefit, and it's no longer significant. So again, agreeing with this idea that the HIIT type protocol might be a better or superior way to control your glucose and your insulin. What about the 3 times 20 second protocol that we featured in the Horizon program? Well, we'd actually carried out these studies with my colleague Nils Vollard in young sedentary people, and Michael's about 55, so he's obviously not young and hopefully not sedentary anymore. What you can see there is again a substantial improvement in calculated insulin sensitivity, no change in the controls. And you noticed in the program that for his insulin response, Michael was a responder. He got a clear, I think, 23% improvement in calculated insulin sensitivity in a period of about 4 weeks. What happened after that program, however, was I get emailed non-stop, and still am really, to give out health advice. So I spent about 3 months answering emails very late at night. I've stopped doing that now. It's not good for my health. But I did get some really very interesting stories, and stories are very dangerous, and case studies are even more so. But this one's worth putting up because this is the blood glucose measurements from a long-term type 2 diabetic who religiously records his glucose levels on a daily basis, and he sent me this data and sent me this graph. And these are his glucose levels early in 2012. This is when the BBC Horizon program ran. This is when he got a bike. And this is when he started doing the HIIT protocols. Now, the reason why I kind of like this little graph is because this guy's a professor of medical statistics. So I kind of believe his data. Anyone who's done any undergraduate statistics will have encountered this individual. So this is nice to see. So let's go back to our health advice, our health guidelines, and revisit some of them. Well, I think the only one I've not touched on is strength training. And strength training, frailty and aging is a totally different talk, which we are looking at, but not for today. Again, we have to reflect on why we had these guidelines in the first place. And this is a personal view. I think that the guidelines have been based on the fact that these are the values or the sorts of levels of physical activity that it's been possible to detect and affect in an epidemiological setting. Now, what that means essentially is that below that level of self-reported in terms of physical activity or whatever other measure has been used, the health benefit has not been big enough to detect, in which case these minimum levels are to do with the methodology we're using. The second perhaps relevant factor is a lot of health questionnaires that look at physical activity don't take into account a 20-second burst of physical activity. It's not recorded. So if you happen to be late every morning and have to chase the bus every morning, that 20-second leap towards the bus, it's not in your questionnaire. And yet we've shown in the laboratory that 20-second burst of physical activity can have a very powerful effect on your glucose and your insulin. So this is probably one reason why we've got to the position we have. What about inactivity? Now, I'm not going to go into inactivity in a great deal either, because again, I've got some other things to show you. But it certainly is something that is getting a lot of discussion. So no longer are a lot of individuals focused on physical activity and the epidemiology around physical activity and health promotion, but they're focused on how long we're sitting down. And for sure, you have to ask yourself, how strong is the data? Well, for sure, if you all lie in a bed, your muscles will begin to waste away. You will become insulin resistant. We can make healthy people insulin resistant in the space of about 10 days just by putting them to bed. So there's no doubt physiologically the data is there. But a lot of the enthusiasm for this is driven by this concept that we're all extremely inactive. This is what's driving the public health problem. And this caught my attention just recently. This is a study where what they've done is compared hunter-gatherers, they're still living as hunter-gatherers today, with people of Western origin. In this case, it's people living in, I think, East Coast of America for sure. The graph's very busy, but if you just focus on the grey dots for the time being, what this is a plot of is the amount of muscle, or rather fat-free mass, so largely muscle, and the amount of energy expenditure they have. So obviously if you're a bigger person, you have more energy expenditure. So what you have to do is adjust for your size in some way. So if you plot this graph here, you plot your fat-free mass with your energy expenditure, you can see the person with a higher free mass has a higher energy expenditure, and it's a sort of linear line. This is all the grey dots are the people from the East Coast of America. If you then superimpose the hunter-gatherer subjects, who are smaller, on average about 20 kilos lighter, much less fat mass. If you plot their daily energy expenditure per kilo mass, you can see it falls exactly on the same line. And really what the authors in this paper argued was that there wasn't this dramatic difference in energy expenditure between people living a lifestyle that we thought we lived a long time ago and modern day life. And really what they concluded, and I guess many other people might conclude, is that we're just simply eating more. We're exposed to high calorific, high density food, and that is really what's driving some aspects of the obesity problem. So it's really a word of caution. You know, if we shift our focus from physical activity to physical inactivity, we have to look carefully at the data and think what we're trying to achieve. Okay, so I'm going to give you hopefully one of the first new truths about exercise. Given the fact that what we've got to work on is risk factors and risk factor modification, a 1, 2, 3 minute bout of exercise per day, 3 times a week, essentially can achieve the same improvements in health risk factors for diabetes related and some cardiovascular disease related factors, so removing the so-called time barrier. I think that if we then think about our public health strategy, instead of asking people to go to gyms, have frequent showers, do lots of laundry, buy lots of sports gear, and so forth, we can just get them to switch the kettle on, go on the bike in the office for 20 seconds, pour the cup of coffee, and then go back to work. There's still some questions. What will the long-term benefits of this type of exercise be? I don't know. But then if you ask the proponents of the 150 minutes a week, actually they don't know either, especially for you as an individual, because nobody has actually taken people through that long-term process. Right, a quiz. See who's been listening, basically. So, true or false? One of these statements is more wrong than the other two, and I would like hands up for who thinks it's A, B, or C. So A, I'll give you a few minutes to read it. Okay, so who thinks it's A? Okay, a few hands there. B? Okay, about 15%. And C? Yeah, 30%, so we're missing about 50% of the audience. Okay. You should have known from the title of the talk it had to be B. If you as an individual take up a regular exercise training program, at this moment we have no way of guaranteeing you as an individual will actually reduce your blood pressure. And I'll show you data why that's the case. Point C is just great. It's another example of a wonderful correlation. This was in New England Journal of Medicine, I think last month. And it fulfills all of the criteria for good epidemiology in a way. Because what you have here is the chocolate consumption, the number of Nobel Prizes, and you see a beautiful linear relationship. Switzerland at the top, they consume the most chocolate, they have the most Nobel Prize winners. The survey even pointed out that Sweden was a bit of an outlier. They award the Nobel Prize, they don't eat quite as much chocolate, but they seem to win more prizes than they should. Let you figure that one out. The other reason why it fulfills one of the rules of epidemiology is it's got plausibility. Cocoa contains flavonols, compounds linked to a slowing of various aspects of age-related cognitive decline. So why not? The chances are, the truth is, this is just a false correlation. It's very interesting. The journal made quite a lot of fun about it. It is fun. But if you go online, you'll see that there's hundreds and hundreds of news organizations that pop up everywhere. And actually, some of them took it seriously. So it depends which website you browse to. And who knows, maybe they're right. Okay, blood pressure. this is perhaps the second truth that I hope to present today. And I'm almost on schedule, I think. Every exercise study that's studied a group of otherwise healthy individuals and put them through a training program has come up with adverse responders. And on the left here is a graph from the Heritage study, one of the biggest intervention studies, supervised intervention studies we have. What you have here is the improvement or adverse response in systolic blood pressure in about 750 Caucasians. So that's a distribution. You can see that some people get a substantial reduction in their systolic blood pressure. Some people get no benefit at all. But there's a group here which are get a bit statistical now, 2 standard deviations away from the measurement error and measurement retest variation. So this is probably an underestimate. But for sure we have in this study, this particular case, about 12% of people that are actually getting an elevation in blood pressure. And anyone who knows a bit about blood pressure knows that it's a very strong risk factor for stroke. So it's a pretty serious topic. If I came through the door to the GP and I had high blood pressure and I was forced to go on an exercise training program before I was given other options, I'd really want to know that I wasn't in this group. I'd really want to know I was in this particular group. And I think this is where we need to be heading. Just to show you that this is not a parameter that just came up in the Heritage study. If you look at Claude's review paper in PLOS 1 2012, anyone can read it. It's free access journal. You can see that in every study he looked at, in both Caucasians, American blacks, and other mixed race populations, including Swedes, including Finns rather, all demonstrated that you could find adverse responders in these clinical trials. Now, if you look at other health benefits and other health endpoints, you get the same story. So this is just a graph of low responders for aerobic fitness, people that can't grow muscle, and people that seem to get more insulin resistant, so they go further in the direction towards the state of insulin resistance and type 2 diabetes with exercise, not away from it. Now that might seem a bit confusing because I've told you that there is very clear data that exercise training intervention studies reduce the development and progression towards type 2 diabetes, but that's on average. The question you have to ask is, did every member of that trial benefit from the intervention? And that's a really, really important thing if we think about personalized medicine. So every study has adverse responders. So do we need to tailor exercise recommendations? Almost certainly. Can we change a non-responder into a responder? Not yet, but we've got some ideas of how that might be possible. Can we prescribe exercise for the treatment of disease? No, absolutely not. And this is probably where I'm most at loggerheads with the majority of the exercise world, because most exercise-related societies, American colleges, sports medicine, have declared that exercise is medicine. Exercise is essentially analogous to taking a tablet. That's a Glaswegianism, I believe, isn't it? A pill. What we really know from our drug trial experience is that not everyone responds adequately to a drug either. Some people have adverse responses, and it really is the same situation with exercise. So how can we spot our non-responders or our low responders? Have a look around. Can you spot one in the room? No, you can't. It's not possible. If you measure all of the simple physiological parameters, height, weight, body mass, baseline blood pressure, various metabolic parameters, you cannot pick out a low responder from a high responder. And this is really where we set down the route of using genomics and genetics to try and give us some sort of clue. So what was the basis for this? Well, we had some good scientific reason for going and spending all this money and time. And that was that in the heritage family study, and other twin studies done in the 80s and 90s, again by Claude Bouchard, what was noticed was that for example, if you had an identical twin and they showed a good improvement in aerobic capacity with endurance training, the other twin would show a good response too. And through those types of studies, and also through the family study, the heritage family study, where groups, 3-4 members of each family took part in the trial, you could calculate how much was potentially genetic. And what we saw from these studies was that about 60% of the gain in aerobic fitness was considered to be familial or genetic. Baseline insulin sensitivity about 40%, strength about 50% in another study which used enormous sample size. So we've got good reason to believe that some of these responses run in families, so to speak. The question is, how do we go and find what genes are actually contributing to that? And if you look at the advances in gene sequencing and gene annotation, then of course we have a lot to play with. But a lot to play with also gives us a huge headache. How do we find the informative genes? So at the moment we have something like 10 million genetic variants thought to be a frequency that might make them relevant for this type of work. Each little gene explains just a tiny fraction, if you like, of the variation between one individual and another. So finding one gene is not going to be sufficient. You're going to have to find lots of genes. And then how useful do we find them as markers? Well, this is my son. And this is the technology we use. He didn't run this particular study, but he was very keen to. This is an Affymetrix gene chip, and here what we're doing is measuring the products of our genes, the RNA molecules in our muscle tissue. And we're asking the question, does the variation in these RNA molecules in our muscle biopsy tissue that we take from our volunteers, does that predict how the volunteer will then respond to the 6 to 10 week training program? And the simple answer is yes. We were very able to not only find a group of genes, but also reproduce that in 3 independent trials. So we get a picture like this, green and red. Red means low, green means high, and basically this is just telling you that the genes are expressed at different levels in the muscle tissue of the volunteers. And depending on whether they were high or low, we could calculate whether they were then going to respond to the endurance training. We also took these RNA markers and sequenced them using tagging SNPs. So a way of trying to locate genetic variance between one person and another, and generated a number of candidates there. So at the moment, we can take a blood sample or a swab from you. We measure 27 SNPs, and we can predict whether you're going to get a good aerobic fitness improvement or not. Now, of course, aerobic fitness is only one major response to exercise. It's not the be-all and end-all. But this is a kind of proof of concept that at least we're going down the right track in terms of the approach we're taking. How do these genes work? Well, the first thing I would say to you is that you don't need to know how they work. In fact, in some ways, I don't even care how they work. All I care about is whether that test is reproducible and can help us give someone advice. We may never fully understand how 27 genes talk and to each other or the rest of your genome. It's too complicated. In this example here, we have our predictor genes, so the genes that we can use from the muscle biopsy that predict the training response. They don't themselves respond to exercise. They're preset at different levels, but they're not responding to exercise. But they talk to multiple genes that we do know are switched on and are very important for exercise adaptation. Genes which are involved in growing blood vessels, improving the oxygen delivery to your muscles. And so, really sure we can talk about the biology, but the important thing is that The important thing is that we have this signature that we can now use in different people and predict a response. What else can we do with this sort of data? And this is probably the last science slide. One of the questions we're asking is, if you're an adverse responder, is there something we can do about it? So if you want to avoid getting that increase in blood pressure, is there something we can combine with exercise that prevents you getting that adverse response? And one of the ways of doing this is using the different patterns of gene expression in the muscle tissue that we're taking from our volunteers and comparing that with what drugs do. So we've got large databases of what aspirin does, for example, or what a beta blocker does, or a number of other types of drugs. All drugs that have been in humans, all nice and safe to a point. And we're thinking, well, if we combine these drugs with exercise, can we solve some of the problems? And this is a method that we're now using to start new clinical trials. Another approach that we have to studying drugs, this time using drugs which have not been in humans and therefore not safe to run clinical trials, is to, of course, trial them out in animal models. Now, if you're going to do that, then you need an appropriate model. And my colleague in Michigan, there's a lot of bad weather and snow there, so she's been pretty bored. And she's been breeding rats for about 9 years now. And what she's been doing here is not doing any fancy genetics, but simply training them, picking the animals that don't respond very well to training, putting them in one house, the animals that respond nicely, putting them in another, and after 15 generations, what she's getting is offspring which are successfully better at responding to training. If you look at this graph, what you'll see here is the aerobic function of the animals at baseline, and it's the same value whether you're a low responder or a high responder. Baseline's the same. As soon as you train these animals, one group can dramatically improve their aerobic capacity. The others just do not respond at all. And they're both doing the same amount of training. What was fascinating as a side observation is that the female high responders will not in any way even look at a low responder male anymore. They're not interested. And that's interesting in itself. So if you look at the details of the if you look at the details of these animals, then what you actually find is that they too can't really grow blood vessels very effectively. There's something in their ability or their stress response to training that actually means they're not very effective at adapting. And it pretty much tells you that if you want to be a high responder, then you probably have to choose your parents wisely, or as Yoda would say, that way around. Okay. Last couple of slides, and this is just a summary of what I've tried to convince you about today. A lifestyle program will, on average, reduce your risk of developing type 2 diabetes. So as a public health message, given that we have no other alternative, we have to tell everyone that this is the way to go. But if you look at the details, and if you ask as an individual, will this work for me? There is no guarantee. Second major point is that currently, as things stand, we don't really know whether exercise training alone on its own will reduce heart disease or angina. It'll impact on risk factors, it'll impact on symptoms once you have these diseases, but will it prevent your chances of having them? We don't know. I think the third one for me is particularly important, and one that we're spending a lot of time and energy focusing on, is that if you have a risk factor for ill health, such as elevated blood pressure, you cannot be sure that exercise will actually help you. 20% won't get any benefit, 12% will actually get worse, potentially worse. And so what we really need there is a diagnostic. We need to be able to say, yes, 70% off you go and exercise, no more excuses. 30% we're going to give you better drug monitoring and better pharmacotherapy. Truth number 2, time is irrelevant. 1 minute a day of high intensity sprint training in your suit, in the office, can reduce your hypoglycemia, improve your insulin sensitivity, improve the vascular health of your blood vessels, improve your aerobic fitness, help build muscle mass, and do everything that we've really known for about 30 or 40 years in the athletic training environment. From a public health perspective, why is HIIT different? Well, cost benefit. I don't know about you. I did a lot of track and field when I was younger, up until about the age of 21 before I got injured. And after losing that sort of competitive sort of reason for doing sport, I found that actually I don't like exercise very much. It's a real struggle to go out and go jogging for half an hour. It feels great afterwards, but every time you're coming to do it, I personally don't enjoy it. So it's a big cost to me as an individual, and probably to other people in terms of busy schedules and other factors. The other thing that's quite surprising coming out of studies in North America is that this type of interval training, this short, sharp burst work, seems to be more enjoyable for most people. More people are reporting it enjoyable than the traditional training. And because of that enjoyment factor, then you've got a chance of having higher compliance. You heard that about 6% of the Welsh population are doing what they should in terms of the 150 minutes. Well, the figure for doing a few minutes of high intensity won't be any different, but it could be different. It certainly could be different if we convince employers and universities and all the people that fund our healthcare to put the appropriate equipment in the right place. The other thing that I like, which is good for our politicians to talk about, is this aspect. If you follow the if you do an additional 150 minutes of exercise a week, you have more laundry, more showers, you have about 3.5 to 4 more equivalents of food intake, and the carbon footprint associated with food in particular is substantial. You, roughly speaking, increase your carbon footprint by about 15%, and it costs you more money. So it's a bit of a no-brainer to suggest that this might be a reasonable alternative to deal with many factors. Workplace, not the gym, or home, not the gym. I think many people don't like the gym. Is it safe? Well, I think there's been some rather substantial analysis looking at marathon runners, for example. So 2 million marathon runners, and the number of fatalities was tiny, minimal. We've got no reason to believe that this type of exercise would be any more problematic, and in fact it has been done in heart failure patients and diabetes patients under controlled settings. There's a lot of concern about this particular topic based on that movie feeling, you know, somebody runs for the bus, has a heart attack. I think statistically you're most likely to die at 5 o'clock in the morning because of hormone cycle changes in your sleep. And so I would argue that this shouldn't be a major factor. Truth 3, and I think the final one, is that what if you're not convinced by any of this, you don't believe in risk factors, but you want to see proof that if you do an exercise training program, 10 years later you're less likely to have a heart attack? Then what we need is supervised intervention trials. To do an appropriately powered, multi-centered, multi-race background, multi-risk factor, multi-exercise protocol, because there's no point just testing one protocol, you need about $1 billion. Some of us have been trying to do one component of that particular study, so only about $80 million, and NIH and others are not interested. $1 billion sounds like a lot, or £1 billion in this case, but you know, it's what the annual bonus of a few senior banking executives perhaps. One-off year. You contrast that with the amount of money a large drug company spends every year. So not until recently, say Pfizer would be spending about $10 billion a year on their research program without really getting any new drugs or really impacting on human health more recently. So it's not that much money, but to go to a funding council, that scares them. What we are doing is point 2 here, and that is we have studies such as the MetaPredict trial that I lead, which is an EU-funded study for about €6 million, where what we're trying to do is generate these gene signatures so that we can advise people what likely benefits they're going to get if they follow just a standard high-intensity interval training program. There, at least, we can move forward the idea of personalization. And also, once you've got that DNA diagnostic, you can go back into all the previous studies and find out why some people perhaps had an adverse response. Why was the benefits in those cardiovascular trials that I mentioned earlier that were stopped early? Maybe it's because 1/3 didn't get any benefit at all. You take them out, suddenly you've got a significant benefit in your other 2/3. But there's no way of doing that now unless you've got some sort of objective marker. So this is the sort of thing that we're now hopefully going to produce. Okay, so I have to own up, none of what I've told you is new. I'll let you read that. This was an observation obviously made a couple of hundred years ago, and I really don't think there's a truer word been spoken tonight than by this chap. It's much more you understand the patient, the context of the patient's genetics, if you like, than what disease they've got or what lifestyle program you're trying to make them feel guilty that they're not doing, etc., etc. Individual variability is incredibly important and something that we have to we have to take into account moving forward. We cannot give public health policies which are based on the average. There isn't an average person in this room. They don't exist. Okay, acknowledgement time. Thank you very much as an audience for listening to me tonight. These are the colleagues that I've had the pleasure of working with over the past nearly 20 years since I started my PhD. The anti-aging cream's working well, isn't it? I think some of the genomics work was done by these people in my lab, but really it's these clinical collaborators around the world that has helped me pull together some of the data that I've showed you tonight. And thanks again for your attention.